Okay, we're now on section 1.2, modeling and alternative representations. Um, a model is a simplified substitute for the real problem that allows us to solve the problem in a relatively simple way. A good example is like when we want to measure, when we want to calculate, we can't measure it, but when we want to calculate the gravitational force between the sun and the earth, well, we don't look at different parts of the earth, and look at the different densities. We just model the earth as a single point of a particular mass, and we measure the sun as a single point, separated by their centers. So we model the Earth-Sun system as 2 points having particular mass separated by a distance, their centers separated by a distance. That's a good example of a model. Okay, so the two primary conditions for using a particle model is the size of the actual object is of no consequence in the analysis of its motion. Any internal processes occurring in the object are of no consequence in the analysis of its motion. So the sun Earth is a good example there. You know, there's all sorts of stuff going on in the Earth, but we can represent it as just a point at a certain mass, and there's a lot of things going on. There's hurricanes, and there's earthquakes, and there's a little dynamo going that gives us our magnetic field. Those internal processes have no effect on our model. So we can calculate the gravitational force between the sun and the earth by representing them as points. Okay, so the first category is a geometric model, and there's other models. Okay. I wish there was something that would distract Nina. Nina's over here messing with my lecture. The second category is a simplification model, where we take out some of the fine points just to simplify the model. The third category is an analysis model, and the fourth category is a structural model. We'll get to those as we come across them. Okay, a representation is a method of viewing or presenting the information related to the problem. So we can look at a ball hit by a bat is a parabola. We can present it that way because we know the physics behind it. Okay, well, get back to this. Okay, and that's it for modeling and alternatives. Next, we're going to go to dimensional analysis, section 1.3.